Hello and welcome to the third video in the SPT Framework series. In this video we're going to cover off the topic of source control or version control. From this video I want you to understand what version control is and what technologies allow us to perform version control on our projects and how this affects you using the SPT Framework. So from the first two videos we already know that there's a series of tools, technologies and practices from the software development space that are coming into the PLC world, into the automation space, and that these are tried and tested methods that have been working for 2 decades or more in the IT world, and that they can really benefit us in the automation space. In the first few videos we covered off object-oriented programming and frameworks, which are part of the design phase of a system, so when you're developing the code in the first instance. And what we're going to cover off today is part of the coding phase, when you're literally fingers to keyboards actually writing the code itself. And the final phase obviously is after you finish doing that, the testing optimization phase, static analysis, profile and stuff, which we'll come on to in later videos. So what we're going to cover off today is source code management, source control or version control, which is effectively a tool that allows you to control your software, how it's developed, by whom, under what practices you develop that code. And then once you've actually finished developing it, how you do feature updates, how you do bug fixes, etc., etc. So if we were to have an idealized version of version control, what would it actually look like? So a version control system would look like something that allows you to record the current state of your project, allow you to make some changes, maybe fix a bug, update a feature, and then save that version of the project. You would then have the files from the original system and the files from the new system, which you could revert backwards and forwards between. You could revert the entire project back if you were to introduce some feature in the new version that didn't work or that did cause some issues with the machine. It would allow you to compare changes over time. So as you do updates to software, it will allow you to track how those updates work. And it would also let you see who actually did the modifications. Okay, so if someone does a bug fix, who that might be. If someone's done a bit of code, you'll be able to go and find out who it was and understand what, and speak to them and understand why they did what they did. But more generally speaking as well, it also allows you to mess up. So if you make a coding change and it's not good, then you can just revert back to the old version of the file and the problem has gone away. And throughout history, there have been a number of different versions of version control. Now, a lot of places you'll go and work, you'll find a version of this system of source control or version control, which is effectively creating a project and making the code, saving that as some version 1.1 or whatever, making a change, saving that as version 1.2, making another change, version 1.3, a bug fix, version 1.4, making a feature update, version 2.1, and so on and so on. The issue with that is it's very easy to make a lot of mistakes. You don't know which one's actually running at which time on any machine, which one you should be using, which one you should be comparing against. And it creates a lot of issues doing version control this way. So one of the first attempts to deal with this was what was known as a centralized version control system. This was a system that sat on a server somewhere that kept a database of all the versions of the project. Someone working on a computer could then download that from the central server, work on it and push changes back to that central server. Then everyone else working on it would then have all of the changes that that person had made available to them. Now the downside to that is that you've obviously got a single point of failure. If the centralized server went down, you'd lose all that. And also if you don't have access to it, you have no access to your code. So there was developed what's known as distributed version control systems. And what this means is you have a centralized source control system, still sat on a server computer, but when you download the files to your computer, it saves a full copy of that entire system on your computer as well. Full copy of what we refer to as the repository on your system. And that way, if the server goes, or your computer goes, or some member of your team's computer goes, you've got backups everywhere where you can then push the code back to and recover everything to where you were, and you never really actually lose the work at that time. And that is what Git is. If you've ever heard of this name, it effectively is a distributed version control system that allows you to take snapshots of your project as you develop the code. Okay. Now you can think of it like a BST image. So when you create a project, you save your project onto the IPC, you add all the features, the Windows layer you need, and you take an image of it so that you can always back up at that point. Think of it like that. It's a really easy way, except you do it as you go through your project. So as you develop code, as you add in the code for your axes, as you add in the code for your Modbus RTU connection, you save one of these images, and that allows you to progress backwards and forwards through that archive or the repository as you need to. Okay, so every time you save with Git, it basically takes this snapshot of your entire project. Now, to be more efficient in doing that, it doesn't actually take a snapshot of the entire thing, it only takes a snapshot of the changes. So it then records the versions of each file for each version of snapshot that you have created. But it allows you that flexibility to go backwards and forwards and undo mistakes that you've made. And that's important because it's used by the largest host for repositories in the world, which is GitHub. Millions of developers worldwide use this to store open source projects or to store large projects, and companies use it as well for their own project repositories. And a vast amount of Git repositories are stored on this. It's not to say it's the only one, there are others, but GitHub is by far the biggest, and it's the one that the SPT framework is stored on, hence this introductory video. So GitHub is not Git itself. GitHub is a online repository of Git repositories for developers. Okay, so that's important. It is not a Git itself. It's just an online storage tool for Git projects. And you can see here, Beckhoff headquarters have their GitHub account where they store repositories for things like ADS. The DLL is on there. Some examples for T2000, for example, is on there. The CCAT interface for FPGAs for the CX devices is on there. And Beckhoff USA has an account, and that's where our SPT libraries are. Cool. So hopefully that's a really brief introduction to source control. You've got the concept of what source control is. In the next video, we're going to look at how we get the SPT framework from GitHub and bring it into your machine so you can use it, and we'll actually start doing some practical coding.